Hello and welcome to the Superposition Guys podcast. My name is Yuval, and my guest today is Niels Bultink, founder and CEO of Qblox, provider of qubit control products. Niels and I talk about quantum control of qubits, scaling up to thousands of qubits, qubit crosstalk, the Dutch quantum ecosystem, and much more. We hope you enjoy this episode. Hello, Niels, and thank you for joining me today.
Thank you. Hello, Yuval, as well. Great to be here.
Great to have you. So, who are you and what do you do?
So, I am Niels Bultink. I am a CEO and founder of a company called Qblox, which is a, a, a company based in the Netherlands. It's a startup or perhaps a scale-up company operating in the field of quantum technology. So we are really in this deep tech, high tech field, and Um, I'm personally coming from a background of physics, so I've done a master's and a PhD in experimental physics, trying to get prototype quantum computers to work. And over the last 4 to 5 years, I've been on this journey together with a bit of a different angle than an academic one, because I've been growing this company called Qblox. So happy to talk about myself, about this company in this podcast. Thank you.
And what made you start the company? Were you part of an accelerator, or you just woke up one day and said, "I want to be CEO of a quantum company"? How did it work?
Well, it started out 35 years ago. No, it actually the idea of one day starting a company, also together with the co-founder Jules van Oven, actually started already more than 10 years ago when we were at bachelor's education, which is, to be honest, already 17 years ago. Yes. And we always had the idea of one day starting a company in some high tech field. And I think after masters, we kind of both went our own way. He went into oil exploration using sensor networks. I myself went into semiconductor industry, and also during these careers, we were looking for opportunities of spin-outs, but we never really found the right subject, the right opportunity. And after a few years in my career, I decided to go back to university because I was missing the physics and in particular the quantum technology. And already early on in this PhD, um, uh, uh, building these quantum computers, I found that this was actually going to be quite a nice opportunity. A lot of uh, uh, technology was being developed within university, and also so it's TU Delft University, but also the governmental institute TNO. A lot of instrumentation was being developed, and it was actually much more engineering than science. And the fact that all this engineering was happening to support the science kind of meant to us that many more labs in the world will be needing this type of solutions, these engineering solutions. So that's how we found the opportunity and decided to take this all this engineering work and turn it into a real products for others to use.
So, what does the product do?
Yes, what does it do? Um, so it's part of the quantum computer stack. So if you look at a quantum computer as a whole, it is built up of a lot of layers and components. Of course, you need a quantum chip, a quantum processor. It's also called, where quantum phenomena are being controlled and being used for computation. But next to that, or as a part of that, there's also a whole cryogenic environment or ultra vacuum that keeps your chip well screened off from the environment. And then next to that, you need a system to control quantum devices. So the quantum chips themselves are actually a bit of that material. They're like registers or pieces of pieces on which you can carry information. But to actually do that, you need a control system, and that's what Qblox built. So we built the system that translates user algorithms, it translates user IDs into the electrical signals that go into the quantum chip. And then after the algorithm is done, the result is also fed back to our control system. So we are sort of the interface layer between the user and the quantum chip, the classical and the quantum world.
Is this aimed primarily at researchers in academic labs, or do you envision manufacturers of superconducting qubits to say, hey, we're going to use Qblox in development or even in production?
I think that's a very good question, and the answer lies in both, and in the fact that it's in a transition. So the whole quantum technology is really in a early stage. So at the moment, I would say the majority of research and development is now happening within academic settings. So right now, also our about half of our customers, or a bit more than the half of our customers, are either universities or governmental R&D institutes. But there is very important pickup within the industry and the private sector happening right now. Meaning big corporates like Google, IBM, Intel, but also big startup companies like Rigetti or Pascal that are now building these quantum computers in a more corporate or industrial setting. So also our market is gradually shifting from the more academic side towards the industry. Um, yes, so that's the transitions that's happening right now, or one of the transitions.
Is the product geared only towards superconducting qubits, or would it support other modalities as well?
Yes, yeah, that's a good question. So um, our products are quite widely applicable with a plurality of quantum chips, and I think that's also one of the nice opportunities. So instead of having to do everything as a vertically integrated company, so trying to do both the quantum processors and the electronics and the software on top of it, um, there's now the opportunity to sort of in terms of having this vertical company have a horizontal company, and that is where what Qblox is more. So instead of doing everything for one specific application, we can do this for a much larger market and also a much larger set of applications. So we support superconducting circuits, quantum dots, trapped ions, and even some photonic systems, which are a bit more exotic, but still in many ways share a lot of the difficulties that other quantum platforms have. So that's indeed the case.
When I looked at your product a few weeks ago, I saw that they say that they scale up to hundreds of qubits. Now, what happens when customers need thousands or tens of thousands of qubits for the ultimate utility?
Yes. So scalability and making our customers empowering our customers to scale up is one of the core parts of our company. So indeed, at the moment, people are working with mostly a handful or tens of quantum bits. So the majority of the market needs solutions in that era. Some very exotic customers need 100 qubit type of systems, or even more than that. But then those examples are very rare. So at the moment, we provide these systems that support experiments up to hundreds of qubits for the biggest systems. And indeed, the coming years, this will further grow, and we are of course very actively engineering towards these larger systems. But at the moment, it's not really yet necessary and desirable to have such large systems. And the biggest reason for that lies not in the quantity axis, but more in the quality axis. So to make these bigger quantum systems useful, the fidelity of the operations, the quality of the operations needs to go up. Because right now the qubits are not yet good enough to actually make use of large systems. So that's another thing that needs to happen, and that's also a very important area for us where we distinguish ourselves. So providing very low noise electronics so that qubits are not disturbed, and also providing many tools to fine tune the qubits and their operations. That's what we're doing as well. So it's to empower the systems to be meaningful, to be scaled in a meaningful way. That's the goal.
Let's assume I have these low noise electronics. Obviously, the performance of the system also depends on the particular timing and sequence of the pulses and so on. One could think about even error correction algorithms or noise reduction. Do you also provide the firmware or sort of the software that drives and achieves better fidelity, or do you leave that entirely to your customers?
I guess the answer is a bit of both. So to really understand how the software stack works, so there are quite some layers in the software and layers in the firmware, or even you can call it hardware or gateware, that need to be addressed to make it a useful system. And where we are good at and where we define our role is in, I guess, the lower layers of this stack. So anything where it is about tuning up individual pulses and gates, and then executing pulses, having high quality signal, being able to tune in a very fast way. That's where our real core competence lies. But also higher up in the stack, there are very important parts that our partners are working on. So if you think of making very good Hamiltonian models of the pulses and the chips, to really understand the interaction at the physics level, that is more where our partners are coming into play. So we especially like working with other suppliers or other parts of the stack for that. That's how we see it.
And how about calibration? I mean, I think that quantum computers sometimes try to run calibration routines every now and then to measure certain parameters that then impact the control signals, crosstalk between qubits, and so on. How do you address those?
Yeah. So indeed. So when it comes to crosstalk in the chips, it is very important to have a very good understanding of the physics of your chip. And I think the task of understanding the physics lies mostly with our customers or other partners that work on this more software layer. Um, but being able to execute the protocols in a very fast and efficient way, that is where we see our part of the problem. So that's where we are always benchmarking ourselves, if like for specific protocols to measure crosstalk and then be able to correct it. How fast can we actually do this? How well can we parallelize the execution of these protocols? That's where our solution lies in these problems.
Tell me, please, a little bit about the company. How large are you? What kind of funding have you raised, if any? What are your plans for the coming 12, 18 months?
Yeah, so Qblox is a bit of an odd company in this whole field. That's because Qblox does not rely on any venture capital funding. We have been able to grow the company in about 3 years to a team of now a bit over 50 people in a very lean and really aimed at doing business very early on. And that has allowed us to scale in a very fast way, but then still on our own, mostly on our own legs. That is the situation so far now. But for us, it's key to keep growing in a very fast pace of roughly doubling to tripling each year in size. So we hope to maintain that still on our own legs the coming years. But if not, then we will look for other ways to finance the company and grow it, because it is at least key to keep pushing the boundaries when it comes to how good our solutions, how much they have an edge on the competition, and how well they can solve the problems for our customers. That's the most important part.
As far as European companies for quantum computers, there's plenty of companies in France and uh, a lot in the UK and a little bit in Germany. I'm less familiar with the Netherlands quantum ecosystem. Could you tell me about anything you can tell me about the Netherlands quantum ecosystem? Are you in collaboration with other local companies? Is there government support, or is it just that you happen to start the company there?
It actually surprises me a little bit that the Dutch ecosystem is new to you, because I think it's quite well known as one of the vibrant places in Europe in particular, but also in the world. And so there has been a leading institute called QTech, partly TU Delft, partly governmental institute, TNO, already for more than 10 years, and also already multiple hundreds of scientists working there. And over the last 5 years, more than 8 companies have spun out of it. So also the network with other companies. I'm sitting right here in a building that is filled with different quantum startups. That's really aimed at quantum startups. And I think the ecosystem and the way of working together between companies in Delft, but also in the wider Dutch ecosystem, is very good and also quite well known. So in this building, there is a company called Quantware that develops and provides superconducting quantum chips. So they actually are one of the few companies that can supply you with a quantum processor. Then there are also companies working on software layers, like Orange Quantum Systems. And there's a company working on cryogenic infrastructure called Delft Circuits. These are just a few examples of the startups. Other than that, there are quite big corporates like Microsoft and Intel who have in Delft on-campus activities, like really employing large R&D groups. So this whole ecosystem of governmental institutes, big corporates, but also startup companies is really a very fruitful ecosystem that shows to strengthen each other. So I think it's a very good place to be for us. And there's a lot of growth in it. At the moment, they are opening. This is the first quantum building, but there are already 2 new buildings on campus that are entirely dedicated to quantum technology. One is going to be for Qblox itself, and the other building will be a new, more ecosystem-oriented building. So that's in a nutshell the story about Delft and also about the Netherlands.
As we get close to the end of our conversation today, I wanted to ask you a hypothetical question. If you could have dinner with any of the quantum greats, dead or alive, who would that person be?
Oof, that's a very good question. So I think well, quantum or scientists, I think I would be very interested to have dinner with Marie Curie, for being a very early innovator, and I would like to understand her thoughts on quantum chemistry and quantum application. But also more recent people like Chad Rigetti. I was actually in a dinner with him a week ago. One of the early, more entrepreneurial, entrepreneurs in this field, like how they see the field, how they think it has evolved. That they've been there as an entrepreneur early on, and in which direction it should go. So um, that's just from the top of my mind.
Excellent. How can people get in touch with you to learn more about your work?
Yeah, they can contact me, of course. So please head to our website, qblox.com, and you will find the right contact details to get in touch, whether it's for recruitment. We're looking for many new people as well. We have many vacancies. Or whether it's to use our systems as a customer or as a partner, we are always open for collaborations. That's what we're here for. So yes.
Excellent. Niels, thank you so much for joining me today.
Thank you, Yuval. It has been very great to be here.